Hi everyone, how are you? I am pleased to present you the project I've done. As a member of the project of constructing a ship of the 16th century with ancient methods, I've made this simulator of the machine that will be used on it to cut the trunks, so that we can observe how it works. This is a simple representation of the program GeoGebra of a machine Leonardo da Vinci designed. Leonardo was an artist and a scientist of the 15th century. Many historians and scholars regard Leonardo as the prime example of the universal genius or Renaissance man, an individual of unquenchable curiosity and feverishly inventive imagination. This machine, which was never constructed, was found between the huge amounts of drawing he made. We can click here to show the text of the problem or to show the images. Now I will proceed to explain you how it works. First of all, we click here to start the animation and here to stop it. These are the four variables I've chosen to change the problem. Here is the time ruler in this problem. Depending on the variables, it will take more or less time the trunk to be cut. Now I'll proceed to explain you the variables. This variable is the speed of the water, which makes the whole machine move. So the higher its value is, the faster everything will go. It has no representation on the draw, but if we increase it and we start the animation, we'll see that it decreases slightly the speed of the machine. Well, that's actually not true. If we have a look to the time, we'll see that it also goes slower. That's because it takes less time to cut the trunk, but in this program it always takes the slider the same time until it ends. So be careful, because your eyes can deceive you. It has no effect on the cuts per meter due to the mathematical calculations right here. If we have a look to the equations, we'll see that it only affects to the angular speed of the water wheel, which modifies the period of the saw and the speed of the trolley in a way that they cancel each other in this formula. This is the radius of the drum. It's quite little right now, so I'll make it bigger. Here it is. Now everything goes slower, so as I said before, that means that everything goes faster. It takes less time to complete the cut. We can see that also on the cuts per meter, which have decreased. That's because it just affects to one part of the problem, the speed of the trolley. This variable is the radius of the water wheel, the most visual one. It has no effect on the cuts per meter, but we can see that it's the only one that makes the machine go slower. If we accede to the equations, we'll see that it is inversely proportional to the angular speed of the water wheel. Finally, the variable r, which is probably the most strange one. It's a relation between both radius, the radius of this shaft and this wheel. It makes the trunk go faster or slower and changes the cuts per meter. So, as you can see, now it's on 0.5. That means that this radius is half this radius. And if I increase it till 1, now both radius are the same. It is the most effective to change if we want to obtain another cut per meter result, due to the fact that we can't make the drum smaller. So that was everything I had to say. Now it's your turn to click on the play button and experiment with this project. I wish you have a nice day and goodbye.